So this is experiment 3 of MDMD, Machine Drawing and Elements of Machine Design. My name is Professor Saurabh Sheth from Mechanical Engineering Department. The aim of this practical experiment is to study about moment of inertia of planar cross sections. So what is center of gravity? Every particle of a body is attracted by the earth toward its center. The force of attraction, which is proportional to the mass of the particle, acts vertically downwards and is known as weight of the body. A point may be found out in a body through which the resultant of all such parallel forces acts. This point, through which the whole weight of the body acts, irrespective of its position, is known as center of gravity, briefly written as CG. It may be noted that every body has one and only one center of gravity. Now centroid. The plane figures like triangle, quadrilateral, circle, etc. have only areas but no mass. The center of area of such figures is known as centroid. The method of finding out the centroid of a figure is the same as that of finding out the center of gravity of a body. In many books, center of gravity for centroid is and vice versa. Moment of inertia. The moment of force P about a point is the product of the force and perpendicular distance x between the point and the line of action of the force, that is P into x. This moment is also called first moment of force. If this moment is again multiplied by the perpendicular distance x between the point and the line of action of the force, that is P into x is equal to px square, then this quantity is called moment of force, or second moment of force, or moment of inertia MI. Sometimes instead of force, area or mass of a figure or body is taken into consideration. Then the second moment is known as second moment of area or second moment of mass. But all such second moments are broadly termed as moment of inertia. Moment of inertia of a plane area. Consider a plane area whose moment of inertia is required to be found out. Split up the whole area into a number of small elements. Here we can see A1, A2, A3. All are the area of small elements. R1, R2, R3 corresponding distances of the elements from the line about which the moment of inertia is required to be found out. Now the moment of inertia of the area I is equal to small a1 r1 square plus a2 r2 square and so on. So I is equal to summation of ar square. Theorem of perpendicular axis, or we can also say this perpendicular axis theorem. It states if I-axis and I-y be the moments of the inertia of a planar section about two perpendicular axes meeting at O, the moment of inertia I-z-z about the axis z perpendicular to the plane and passing through the intersection of x and y is given by I-z-z is equal to I-x plus I-y. This is a perpendicular axis theorem. This is figure 3.1 explaining the perpendicular axis theorem. Theorem of parallel axis or parallel axis theorem. It states if the moment of inertia of a plane area about an axis through its center of gravity is denoted by Ig, then moment of inertia of the area about any other axis AB parallel to the first and at distance h from the center of gravity is given by Iab is equal to Ig plus Ah square. Here it is nomenclature. Here we can see IAB is equal to moment of inertia of the area about an axis AB. Ig is moment of inertia of the area about its center of gravity. A is equal to area of the section. H is distance between the center of gravity of the section of and axis AB. So this is parallel axis theorem figure. Okay, this is a figure of parallel axis theorem. Here we can see the entire parallel axis theorem explained. So we conclude this experiment, and at the last of the experiment we have two application based questions. First one is find the moment of inertia of rectangular section, and second is find the moment of inertia of a circular section. Thank you.